Okay, first endeavor into remote learning here. This is the worksheet that we were working on right before we left on Thursday, the day that we had the quiz. And what I'm going to do is I'm going to just quickly review 30, 60, 90 right triangles and 45, 45, 90 right triangles, and then work through the back side of the worksheet. So the first thing is for a 30, 60, 90 right triangle, here's a 30, 60, writing with these pens is terrible, but the side that's opposite the 30 is x. The side that's opposite the 60 is x times the square root of 3, and the hypotenuse is 2 times whatever your x is. In a 45, 45, 90 right triangle, the two legs are x, and the hypotenuse is x times the square root of 2. If you flip over to the back side of the worksheet, first problem here is an equilateral triangle problem. So I'm going to draw an equilateral triangle. Each angle, of course, has a measure of 60. And then it says to draw in an altitude. So I'll draw an altitude, creates a right angle with the opposite side. Side length is 2. So each of these little triangles are 30, 60, 90 right triangles, where the hypotenuse is equal to 2. So that's my 2x side. My x side is half of that, or 1. And my side that's opposite the 60 is going to be the x, which is 1, times the square root of 3. So it's just the square root of 3. And that would be the altitude. For problem number 2, here's a square where the perimeter is 48, so each side is 12, with a diagonal that splits the square into two 45, 45, 90 right triangles. This hypotenuse is going to just be whatever my x side is, which is 12 times the square root of 2. So it's just going to be 12 times the square root of 2. Third problem here is a kite problem. So you got to know the properties of kite. You know that in a kite, one of the diagonals perpendicular bisects the other one. So this one is congruent to this. And it's given that this is 5. This is TK is 10. So, and it's bisected. So each of these are also 5. And then YE is 12. So I can see, hopefully, that in this right triangle here, it's a 5, 12, 13 right triangle. And for this right triangle here, it's a 5, 5. So that makes it isosceles right triangle, or a 45, 45, 90 right triangle. So both the legs are 5, which makes this side 5 root 2. This is also 5 root 2, and of course this side is also 13. Problem number 4 here looks like a sunshine problem, but it's actually a 30, 60, 90 right triangle problem. This is 30 here. BC is 10 root 3, and that's my hypotenuse side of this right triangle here. And if this is the hypotenuse, 10 root 3 is, then this is my x side, so it's going to be half of that, or 5 root 3. And this side, of course, is going to be my x, which is 5 root 3, times the square root of 3. So root 3 times root 3 is 3, times 5 is 15. So that side right here is 15. And then I can focus on the big right triangle overall here, where this side is still 10 root 3. That's the side that's opposite of my 60 degree angle, because this is 60, this is 30. This is a right angle still, which means that the side opposite my 30 is my x side, so this x is just going to be 10, since this is x root 3. The hypotenuse is double my x side, so it's just going to be 20, which means if this is 15 here, this part right here is 15, then this little portion right here must be 5. And then the last problem is another square with a diagonal, which splits it into a 45, 45, 90 right triangle. The hypotenuse this time is 10, or my diagonal is 10. And that's my x root 2 side. So if I divide both sides by root 2, I get x equals 10 over root 2, rationalize the denominator by multiplying by root 2 over root 2, and I get 10 root 2 over 2, or 5 times the square root of 2. That's going to be each of my side lengths of my square, and so 4 times 5 root 2 is just going to be 20 root 2 for my perimeter. And that's it.